Today I really want to talk about serverless Puppet. So if you're still trying to deploy Puppet servers into a cloud-native environment like AWS, then there really is a better way. The traditional Puppet deployment of a Puppet server with Puppet agents connecting to it and downloading their manifests, it's not a model that fits in today's cloud world anymore. Having to worry about cleaning up SSL certs for short-lived instances, having to update code on your Puppet server as part of your CI pipeline, and having to bootstrap all your instances with the Puppet agent package to make sure they can all connect. These are all things that I think hold Puppet back in a cloud-native environment. When we look at other tools in this space, look at Terraform, look at Ansible, they're all decentralized sort of push model architecture. And Ansible's a really good example. When Ansible launched, it gained popularity extremely quickly. A lot of Puppet users migrated over to it, and one of the reasons for that is it gave users what they wanted. It gave developers the ability to check out a repo on the desktop and push changes. It made it easier to integrate into CI pipelines. And I think Ansible's decision to go with the serverless decentralized model is what gave it its win. And as much as I really love the simplicity and the ease of use of Ansible, I still love the Puppet language. I still love the declarative nature of Puppet. I love things like data lookups with Hiera, and they're not things I really want to sacrifice. But at the same time, I want to be managing my systems with Puppet. I don't want to be dedicating so much time to having to maintain the Puppet infrastructure itself. A lot of this for me is just extra stuff I don't want to think about. And the concept of serverless Puppet isn't exactly new. People have been running into this friction for years. Up until recently, that's still been problematic. It's still involved copying over all of your Puppet code onto all of the agents and then having to write some orchestration to kick off Puppet agent. So it's always felt that Puppet's been lagging behind in this space for quite a while. So Puppet a few years ago released an orchestration tool called Bolt. And despite the fact it's actually been around for quite a few years, I don't think people are really taking full advantage of what it can offer, especially around doing serverless Puppet and Puppet in a cloud-native space. The Bolt tool itself is pretty versatile. It's an orchestration tool that can run tasks and plans across your infrastructure. So I started experimenting with it a lot recently with a view to solving my issue around serverless Puppet. And I've got to admit, it's a game changer. I'm now currently moving all of my workflows over to using Bolt. I feel like I've got the best of both worlds now. I've got the language features, I've got Hiera, but I don't have all the overhead of worrying about Puppet infrastructure, and I can tie this stuff straight into my CI pipelines and it just works. So let me quickly show you this stuff in action and stick around to the end of the video for a bit of a free gift. So I've just spun up an instance in AWS using Terraform. This is a vanilla Ubuntu AWS instance with a AWS key pair for SSH access. So I've done nothing else to it. We've not installed Puppet. This is as vanilla as you get. So now let's see how to take this minimal instance and apply our configuration to it using Bolt. So all of my Bolt stuff lives in this directory structure. So this Bolt repository is almost identical to a traditional Puppet control repo. There's some extra stuff that we're going to go over in a minute. But if you're familiar with best practices in Puppet, then a lot of this should be really familiar. So the first file we're going to look at in this project folder is the boltproject.yaml file. And this contains some of the base information about my Bolt project. So the name, which is Bolt Demo. So let's take a closer look at this module path entry, where I've given it a module path of site. So this tells Puppet to look under here for extra Puppet modules. And in this case, I've got my profiles under here, and I've got one profile written, which is my profile base, which is just responsible for including my NTP accounts and sudo modules. And below that, we got a list of third-party modules that we want to pull in. The information we're giving here is very similar to a conventional Puppet file. So just like a regular Puppet file, we can specify a module name, a location where to fetch it from, a version that we want to deploy, and resolve false just tells Bolt not to try and resolve dependencies within that module. And that's all we need to initially bootstrap our first Bolt project. So let's have a quick tour of the Puppet configuration that we're hoping to apply to our target node. So we've seen here we've got our profile base that lives under the site subdirectory. Just like a regular control repo, I've also got my hiera.yaml here, which specifies I've got my data in a subfolder called data, and right now I've just got one hierarchy called common.yaml. And if I check here under data, I can see that I've got some basic configuration in here, some sudo config, and I want to add my user with my SSH key to the instance. This bit's no different than regular Puppet with a standard control repo. So this is where it gets a bit interesting when we look at inventory.yaml. We use inventory.yaml here for two things: to define what our infrastructure is, so to actually tell it about our servers and what they are, what groups they're in, and how we want to connect to them. Bolt's got a lot of different transport options. We're going to use the SSH, which is pretty standard. As I said, I've got a minimal AWS instance, and that's been configured with an SSH key pair that I've got in my home directory here, so that can authenticate me. By default, AWS gives me a user of Ubuntu with sudo rights, so I want to SSH in as Ubuntu, but I want to run my configuration as root. So that will run sudo under the hood, and I'll be able to perform all my actions as root. So in order to run serverless Puppet, we need to create what's called a Bolt plan. And if we have a look under the plan subdirectory here, we have a plan called puppet.pp. So Bolt demo Puppet plan. And this is actually written in the Puppet language, in the Puppet DSL. So we've now got a new construct called plan. This is a really minimal plan. So we just take in one argument, which is the targets, so the servers that we're connecting to. The first stage of the plan, we're going to call this apply prep function. So that will make sure that Puppet's installed on the agent server, which it does over SSH as well. And it will gather all the facts from the agent. And then those facts are going to be used when compiling the catalog, which happens in the next step. So here we can see we want to apply to those targets, and then anything within these parentheses is what we're going to run. So in this case, we're just going to include profile base and then let regular Puppet, if you like, the rest of the Puppet code take care of it. So the first thing we need to do before we can run Bolt against our target nodes is pull in all of these modules and install them locally. And we do that with a Bolt module install. And this will read in the contents of the modules entry in your Bolt project.yaml, generate a regular Puppet file off that, and then we'll pull all those modules in. So we can see it's created a Puppet file and it's synced the modules to the current directory under a subfolder called .modules. If I have a look at that, I can see I've got my 4 Forge modules deployed in there. So now we're all set to run our Bolt plan to run Puppet on our target nodes. So this is the plan that we're going to run, and we do that using the bolt plan run command. Bolt plan run. I'm going to give it -v so we get some verbose output, and give it the name of the plan. So I want Bolt demo Puppet. And then finally, we need to tell Bolt what targets we want to run this plan on. So you could just go target -t all, and that will pick up anything that you've got in inventory.yaml, or you can give it a group name, or you can give it an individual server. So if we look back at my inventory.yaml here, I've only got one server in there and it's in a group called demo. So let's just give it demo, the group name. So the first step is it actually connects over SSH. It will install everything it needs locally. So it'll install Puppet. You don't have to worry about that in your bootstrapping process. And then once that's done, it'll get the facts for this node, and then it's able to compile a catalog. Boom, there we have it. So we've got a successful Puppet run. We can see here that we've done some NTP management. We've added my user and my SSH key and my sudo rules. So I can make sure that's working with my own user. And there we are with my sudo rights. So there you have it, serverless Puppet with Bolt. As I said earlier, I'm moving all of my stuff to this model now, all of my workflows. It's super easy. It fits in so well with CI pipelines. I use GitHub Actions a lot, and it means when I'm pushing Puppet code, my workflow is literally hit merge. So this was a really quick fire intro and demo of Bolt to do serverless Puppet, more to demonstrate how I'm using it in my workflow and the benefit that I've got out of it. But Bolt's a really versatile tool and does a whole lot more. And I'm going to be doing some more focused drill down videos into other Bolt features. So if you've got any ideas of what you want to see in future videos, then leave a comment below. Also, if you want to play with this stuff on your own systems, then the repo that I used in this demo is up on GitHub, and I will put the link below, so feel free to go and grab it. If you like this video, then YouTube has a special button for that. I'm Craig Dunn. See you in the next one.